Got it. Okay. So this week had some distractions, so I didn't get a whole lot done, but came down last Saturday morning to a dead Unix laptop. It completely blank screen. So tried a bunch of things. F2 wouldn't work, F12 wouldn't work. I tried an external monitor, nothing. So I giving up on that laptop and trying to use another laptop that I had lying around. Found a USB drive that had Ubuntu on it that was bootable. So I went ahead and booted it, tried booting it, had to go into the BIOS and make sure that the USB was where it would look first. Was able to get it to recognize that. Started getting a bunch of errors that it couldn't read the device once it got beyond a certain point. And so after checking with my friend Google, he said that when you get to the Ubuntu screen, to pull out the thumb drive and then just put it back in. And that actually fixed it. I was able to continue on and was able to load Ubuntu and got it all up and running. Started doing some configuration on it, adding some tools, getting networking and all of that set up. Then I tried loading ROS1 and said it couldn't find it. When I Googled that error, it said, you're probably running on Ubuntu 22.04 instead of 20.04. And sure enough, I had loaded the wrong version. So I had to go back and make a new bootable thumb drive with the 20.04. Then this morning I tried booting from it. Was getting the same device error. So I tried unplugging it when I got to the Ubuntu screen, plugged it back in, and it said, okay, now checking file system. And it goes through this whole thing. And then now then it takes me to a purple screen that has nothing on it, but I can see the mouse pointer. So 2 steps forward, 1 step back.
Sometimes you just have to wait a while. When you're first loading these things up, it comes up with a stupid screen, a blank screen or whatever, and you can see the mouse. Sometimes you just have to wait a long time before it decides that it's finished setting up or whatever. So that's something to consider on that.
30 minutes.
Well, it seems like 30 minutes should work on that. So again, try plugging in an external monitor on that. It could be it doesn't like the video driver or something of what you're doing.
Hadn't thought of that, but I think this has a HDMI port on it, so I can try that one.
Back to your first computer. If you plug in the charger into the laptop, is there a little light that comes on that says it's plugged in and sees the charger?
The white light does show.
Okay, because I was thinking it could be just your charger died and the thing just ran down, and now your battery's just dead. So that's something else to consider. That maybe it's just your charger's bad, but
that could very well be. I see lights on it. But they're kind of like it's behind the F12 key and behind one of the other keys. But it doesn't really say what it's for. So I'd have to do more research on that one. But I've started Google Doc. I need to share it, I imagine. Okay, so for this week, let's see, the compact die, kind of gone through all of this. So I'm going to try and my plans for this next week are to get the Ubuntu 20.04 loaded onto the Acer laptop, then load ROS, get ROS loaded onto that laptop, and continue with the things I had from last week, which were breadboarding all of the functions for the Itsy Bitsy, which include adding the A to D, adding the serial communications to my Raspberry Pi, move it to a solderless breadboard, or away from the solderless breadboard onto a breadboard, mount the breadboard and motor controller on iSnow 1, start VNC server on the Raspberry Pi, and continue or start playing with the tutorials for ROS on the laptop. Any questions?
No, I guess not.
None for me. I just had to chuckle though. Your accomplishment was that your Acer died.
Well, not the Acer, it was the compact one that
Oh,
died.
okay, yeah.
But yeah, that was, don't know what happened with that one. But I had obviously stopped using it for Windows for some reason, and I don't remember what, because I've got those, like I said, I've got 4 laptops sitting around.
Ample spares.
We would hope so.
Jeff, you want to go next, or do you want me to? I don't have much.
I could go next.
But fire away.
So last week I was saying I was trying to get all these little boards that I was buying. I was trying to get them to work with Arduino. You can get Arduino for the ST micro parts, and I've had ups and downs and much frustration. I think I finally decided to give up on Arduino for these boards. If I use the Bluepill board, I have some props here. Well, here's the Bluepill board. Speaker. So the Bluepill board is it's a little longer than an Arduino Nano. It's got a STM32F103 processor on it. So it's a 48-pin processor, and it runs at 72 megahertz, I think is what it is. And it turns out on the Arduino IDE for this board, it will indeed work. I can get the USB to talk. I can program the thing. And when I do my extra stuff, I'm trying to get my quadrature encoders to work, and I have to go in and I have to play with the registers to make that work. And I can actually get that to work on that board. So in reality, most of the stuff I want to do looks like it would work on the Bluepill. So then I bought the Blackpill board. I lose everything. Well, I can't find it right now. So I had one loose here. Oh, here it is right here. So the Blackpill board, I'll turn off my background. Choose virtual background, none. So my Blackpill board, it's I think it's got like 4 extra pins or something over the Bluepill, but I think those extra pins are actually just things like it's bringing out the USB connections, and I think it's got the voltage references for the A to D coming out. But otherwise, it's about this. It's the same concept. This one has a USB-C as opposed to a micro USB connector, and it's also got. They both have this adapter out here to plug in the little these things, the little debugger port. So that's why I've been programming the thing. And it turns out on the Blackpill board, I can power it up. I can talk out the USB. But when I load my code for the encoders, which is using talking to the registers, it will not work. And I have no idea why. I've been fighting with that, and I keep changing it, and I cannot get that to work at all. So I'm thinking it's something in their configuration. When they started the thing up, it's supposed to go down the line and configure certain things, use certain files. And I think something there is not working. And I haven't figured out what the problem is with that. So anyway, both of those two boards, I can get the USB to work, and they seem to do standard Arduino functions, but only one of them will let me play with the registers and make my encoders work. So then you can move up to this board, which is the that's a F407 processor, and it's got twice as many pins. So it's a 100 pin part on the board. And one of the drawbacks is the advantages and drawbacks. It's got dual row headers here. So there's a dual row here and a dual row here. So you have almost 100 pins on this board, but you can't plug it into a proto board. Say like on the small ones, you can plug them into a proto board like that and just stick wires in and everybody's happy, but you can't plug this one in to a proto board because it's got two rows of pins on the thing. I suppose you're really clever. You could just solder in a single row here and a single row here and get it to plug into a proto board. But sure enough, the pins you want aren't going to be there. So I've got this board, and if I've got this one or the F4 Discovery board, which is the official one from SD Micro, and it's got essentially the same processor on the board. The little one here has half as much memory as what the big one does over here, but otherwise it's the same basic processor. And let's see, what was I going to say? Oh, so I tried to get this to work with Arduino, and I cannot get this board or this board. Neither one of them. I can't get the USB port to work. So I go through and I put in the code and say, I just simply say, here's the board I'm using. Load up the Blink and Hello World program, and I plug him in. And it says, oh, my D message under Linux says, no, I don't understand that. I saw you plug something in, but I can't initialize that port. And again, I can't figure out why that is. So I think that also comes back to something in their configuration files doesn't understand the board that I have and is trying to run the right stuff. So anyway, that's a problem on those. Now, if I go back and use the ST Micro development system, it's called STM Cube IDE, I think is what it's called. And it's this big thing that's Eclipse based editor and has massive compilers in it, and it supports like 500 different chips or something. And that thing, if you're willing to go to the trouble and load it up and write code for it, because you have to write all the code from scratch. They've got a bunch of libraries to give you, but say if I want the A to D stuff to work, I have to, if I'm lucky, I can find one of the libraries I can drop in and it works fairly quickly. And the USB stuff was quite simple. I just said enable the USB and load what they call their middleware, which is the libraries to talk to the USB. And then I basically did that and compiled it. And then my USB port was working to the point where I can just say, I have a call that you say, it says something like call USB FS for full speed transmit, and you just pass it a buffer of data. So you just say, put the string into this buffer and then say, call that routine and pass it that buffer and the length of the buffer, and it just magically shows up at the other end. So that actually works out fairly well. And I think I've got, I can go in and configure, build a project for the Bluepill, the Blackpill, and whatever this board, let's call this the F407 board, because I don't think it has an official name for it, but anyway, any of those I can create a project. I can get the USB to work on all of those. I can get my encoder to work on the encoder stuff to work on all three of those boards. This board I can't get the USB to work, and I think it's an on-the-go port, so it's got some extra switching and stuff in there that maybe that's why it's not going to work. I have to be smart enough to run that, and so far I haven't figured that out. So I'm really down to the point where this happens to be the Blackpill board. I got it stuck on a proto board, and I got a couple pots put on because last night I was trying to get the A to D stuff work, and I got those to work. On Arduino, you just simply say, initialize that pin and do an analog read. But it's a little more complicated to make it work on this. But I found some examples and put them in. And now if I turn these pots, they go 0 to 4095, both of them. So that's working. And I've got the encoder stuff loaded on here. And then I've got the, I have at least, I got three more timers. One timer that says generate 0 to 100% PWM to run the motor. And another timer that says generate the pulses I need to drive an RC servo. So it takes the full 16-bit value, and I've get the right prescalers. I can make that wrap over at like 60 hertz or 30 hertz, whatever I want. And then by putting in the numbers, I can control the width of the pulse. So you got this big long thing like this, and then out here at the beginning, you can control the width out here to control the servo. So I got that timer, and then the other timer, I just set up a 1 millisecond time base. So I just configure that one. So, once a millisecond, it's going to call and interrupt, and then I can use that for whatever timing I want to do. So I'm thinking at this point, as I say, I think I've given up on the Arduino stuff. I might come back to it someday and try to figure out what's going on, but I can go out, I can program these boards with the big IDE, and that's basically where I'm at right now. I started putting this together. I got the 2 analog inputs working, the 2 encoder inputs working, and I can actually copy the code from my SAMI 2, being the same processor family. I can copy that code over, but I changed the clock speeds on these things because the Bluepill runs at 76 megahertz, the Blackpill runs at 84 megahertz, and then the F407 boards run at 168 megahertz. But in order to be able to copy code back and forth directly, if I slow the big board down to the 84 megahertz like the Blackpill, I can just go ahead and grab a chunk of code from here and drop it in here, and the thing will run directly. I don't have to go fiddle around and say, well, what prescalers do I need and all this kind of stuff. So I'll probably do that so I can get those to work. Anything else important I have to say here? So really, those 3 extra timers, I just have to go through and initialize each one and put my scope on and make sure they're doing, giving me the frequencies and the pulse widths and all that stuff to make it work. So that's kind of where I'm at on that. And other than that, here's what I was doing to test my encoders. I had this motor laying around. This is what I call the small Pitman motors. So this is about half the size of the one that I have on my robot, and Terry's got the same motors on his robot that my current little robot has. And this is a smaller one. It's like a half to 3/4 of the size or something. It does not have a gearbox on the front, but it does have an encoder built on the back. So I was just using that as an encoder, so I can just turn the thing like this and see what the thing's doing. And I can verify by putting it's got these holes in here, like say this one right here, and then on my gear, I just put a mark on there with a Sharpie. So what I can do is I can line that up. This is all backwards. So anyway, if I line it up like that, pointed at that screw right there, and then reset the processor, I should be able to turn it 1 full turn and predict what that's going to be. And sure enough, that comes out to 384 counts by doing one full turn. So each one of these encoders has different number of counts per revolution. This one happens to be 96 counts per revolution, which is really typical for the Pitman motors. You can get ones with higher. You can get up to like 1,000 something, but just these all came from the local surplus store. So basically, you take what you can get, and so that's what I was doing on that. And then on my SAMI 2, I've got one of these Chinese encoders that they're around $10 to $20 depending when you buy them and what the resolution is. And it's real nice. It's got ball bearings all the way through. It's got a 6mm shaft, and I just went through and soldered some of the jumper leads onto the end of it so I can plug those in order to test it. So that's something I can test with. And I guess trying to think if there's anything else that I've done. Basically, when I'm putting this thing on the proto board, I just want to put down out at the end here. I've got all this room down here. I'll just plug in some header pins, and then I can plug in. See, like I've got these. I can plug into the header pin then to make my connection. And the wires coming from the Pitman motor on my actual robot, they're 6-pin connectors. And I'll just put 6-pin headers here and plug those in, and then just run wires from here up to my board where it needs to go. And then other than that, the other physical connections, I need 3 wires to go to my motor power driver, and I need the 3 wires to go to my RC servo, of which I only need 1 of those. Plus, I suppose I have to decide where to hook the grounds up and when not to hook the grounds up. But that's just a matter of putting extra connectors down here on the board and plugging stuff into it. And the only other thing I've thought of right now is I've got the voltage signal out of the new RC servo will give me a position out of it. I'm gonna have to do some playing around with that. I'll probably have to buffer that so I don't load it down, and then after I buffer it, then I can put a voltage divider to get down to 0 to 3.3 volts, and then plug that into it. So that'll be a single wire, possibly with the ground on that. And I guess back to the fact that I like to plug my remote control directly into my low-level board. I was also trying to get my UARTs configured on this thing. So I wanted to have one UART that will talk to the remote control unit, and then have another UART like Terry wants to do, where I've just got an extra port that does not go through USB. And because I'm back to that problem right now, I loaded up Putty last night, and I fired this thing up and said, okay, connect So I start the program and it's, you know, trying to put something out the USB port. So I start up PuTTY and so I load it, and then the numbers come click, 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 click down the screen. But as soon as I unplug the USB cable, PuTTY just dies completely. It just goes away on me. Now, if you use the actual a physical UART and go through an FTDI connector, then your interface doesn't die every time you unplug, you know, either reset the processor or turn the processor off or unplug the processor, because you still got the connection between the FTDI adapter and your laptop or Raspberry Pi, whatever you're running. So I wanted the 2 UARTs, and that's the other grievance I have with these little boards. They've got a lot of peripherals and not really enough pins, so you have to pick and choose your peripheral and see which pins it takes, and that's going to interfere with a different peripheral. So it gets real frustrating trying to go through that. But I finally got to the point where I got my 2 encoders, my PWM to drive my motor controller board, motor driver board. I've got the output to drive the RC servo, and then I wanted 2 UARTs, one to go to the remote control module sitting next to it, and then the one I can use for debug or whatever. And it got down to the point where I could not get both UARTs to work. And then I think it was yesterday I was playing around with it, just kept moving stuff around, and finally got to the point I've got both UARTs configured now. So I think I'm at the point where that's all I really need to do to make this stuff work. I do need to go through and take my my LORA board, the one that's got the radio and the processor all on it. It's like the one that's in my remote control box, and I just need to program it and then hook the UART between that one and my new board here, and then I'll be able to, you know, pick up my existing remote control and drive it around, or can at least control everything using that. So that's kind of where that needs to go. And other than that, I guess it's just a matter of I just have to sit down and finish off testing all these peripherals, make sure they're doing what they're supposed to, and they're running at the right speed and all this kind of stuff. So that's so I'll ask, is there any questions on any of that stuff that I've been babbling about?
Which of the blackboards or Blackpills do you think you're going to end up using?
Well, to start with, I'm going to use this one. So it's the small one that's got I think it's like 42 pins on the board, and I'm going to start with this one, and then probably because it's a real pain, as I say, trying to take the peripherals and the existing number of pins and get them to all exist at the same time. But if you go with a big one like this, it's got twice as many pins. It makes it much easier to do that. And also the bigger chip that has more peripherals. So it probably has more I2C interfaces, more SPI interfaces. I think it's got up to 6 UARTs on this board. Whereas the little board claims it has 3 UARTs, but I go into the software and it says, oh no, UART 6, it's in red, and for some reason I can't use that one. So I can only do 2 UARTs on that board in the first place. So it's just a matter of, I'll probably start with this little one because I can just plug it in a proto board, and I was able to get it configured to the point where it should work. And then when I decide that's not going to work, then I take the smaller board like this, or take this board. It's the bigger processor, and that makes it much easier to configure everything. Because if I say set up my UARTs, my decoders, then they're not going to directly interfere with each other. So it just makes it much quicker to do that. But then it's harder to deal with, because then with the dual row headers, and see here, I've got these one side I soldered the pins on, and so I'll have to get some kind of socket, and I'll probably just take like a perf board like this. This is what I did on Sammy too. I'd take a perf board and then soldered down 2 of the dual row socket boards. So then you just plug this into those sockets, and then you got all this room out here to put on connectors or whatever you need out there and make that work. So that's the first thing is I'll use the small board, and until I have a really good reason to swap that out, then I'll move to this next bigger board. But that's more work. I have to solder the things down. I have to physically solder wires between everything. I can't just plug them in, unplug them like you do on the pluggable breadboard. So.
And the encoder that you held up that you had put on the looked like female receivers, you're going to connect that ultimately to your drive wheels to determine the position of those? Is that where you're going to use that encoder? I'm
just using this encoder just so I have something I can physically grab it and turn it right now to verify everything's working. And that's the same concept with this motor. I just used it because it was a convenient way to get an encoder. And I've got some giant motors out here with encoders. I could have used any of them, but the ones that are on the robot right now, they look like this, but it's got a big gearbox here and then a belt drive to my wheels. So basically the motors that are on it already have the encoders built in, just like this one's done. And then it's got the gearbox and then a belt to run the motor. So that's why it, and those are already on the robot. I just have to simply take those connectors and plug in. And I was saying that, see, on my, if I use these, it's a single inline header, and I bought these at not Adafruit, the local Micro Center. If I go into Micro Center, on just on the shelf, they've got these bags. You can buy these headers that they're damn it, they're long on both ends, which means you can plug them into your plug them into a proto board or plug them into whatever you want. Whereas the short ones, this is actually a double row one, but you see, normal ones just have a short one on one side and long on the other side. So you solder this onto a board and you can plug your jumpers in here. But the one I just dropped on the floor multiple times, you know, the length is like this, where you can plug it into the proto board and then plug a jumper on there. And I had some that are really long that came in some scrap stuff I got one time. The pins are like twice as long, sticking out both sides. So I'm guaranteed those will work because they're long enough. Yeah, I can plug those in anything I want. So that's, again, just for prototyping, that's just a quick way to you know, plug something like those jumper leads that I showed on that encoder, you know, these kind of things. I can plug those into these kind of things, and then plug the header into the proto board. So that's just a quick way to get all the stuff tied together without soldering or anything. Then at that point.
Cool. No other questions for me?
Okay, well then I guess we'll turn it over to you then.
Okay, let's see. So last we spoke, I was going to go work on a wheel-based ODOM statement. So I've got a draft of a program I'll walk through quickly. I was struggling to test that because my IMU package that comes from an outfit called Chip Robotics wasn't in my, I have two workspaces that I've been using. One has a whole bunch of stuff, and the other that I'm trying to keep really streamlined. This ROS1 workspace is the one I'm trying to keep really streamlined. And when I put the IMU package in there, it wouldn't work. And so just like Terry's frustration level was high on hardware problems, I was fighting through trying to get a clean cat could make with this package. I also have got a shell, what I'm labeling a shell of a program that'll switch between wheel ODOM and RTK based ODOM, but it's just a shell at the moment. So, but I've at least started on that. Next steps for me, I've got a launch file that wasn't working. And again, it goes back to this IMU. I'll show that in a second. I want, because the IMU that I have, or the way that it's been packaged by this outfit called Chip Robotics, every time you start it, it starts at 0 yaw. And so I've got to update the launch file so that I can, you know, guesstimate what the yaw is and update that so the IMU starts off, I think, in a reasonable manner. I've got to test my ODOM wheel Python script.
Would it be setting the yaw or setting the direction? Because isn't yaw the movement?
I'm going to, depending on who you talk to, I mean, there's probably a more proper way to say it. There's heading, and then, which is typically, it'll be based in radians. So one, you know, half a pi is, I think if I get it right, half a pi is south and negative pi is west and positive pi is west. So it's setting that.
Okay.
I would say that at least in this case, heading and yaw are the same thing. You're thinking of rotational velocity, which is your change in heading or change in yaw. That gives you a rotational velocity out of it.
Which is what I thought most IMUs give you.
IMUs give you lots of things, so you just have to pick and choose, and depending which ones you buy, some have more information than others. But yeah, there's different fields in there that tell you lots of things that are going on.
Yeah, I mean, I don't think I have, let's see, do I have something handy that says what I'm getting? I mean, there's an actual message, an IMU message. But I've forgotten off the top of my head what are all of the data elements in there, but this is my current wheel odom. I'm not a good programmer, but I'm trying to use a class, which has been a learning exercise. Covariance, I still, matrix math, you guys are probably smarter about that than me, but figuring out covariance is a sort of I just cut and paste stuff is what I'm doing at the moment. So it gets the left meters traveled, the right meters traveled, does this fancy math to update to help build to give me an X and Y position in order to build the odom statement, and it needs to load this quaternion, which I get from a yaw in radians. So anyway, that's just, it's not very long, 100 lines or so without comments. That's one thing. And then let's see, do I have my, no, that's just my procedures for testing that thing. Thought I had my launch file up for working with this thing, but it'll all be out on GitHub. But yeah, so that's where I'm at the moment, is getting a launch file that'll run and bring up RViz and the IMU and the wheel odometry with my map, so that I can sort of test all of that working together and get that initial heading in there. Yeah, and then when I get back out in the road or in the yard to figure out where I'm going to use a PID for speed control, or just have a bit of a table of speeds and servo settings. That's still yet to be determined. And then that's where, so I'm, happy with progress, but it's frustratingly slow. Guess you don't know anything about that, do you, Terry?
Not at all. One step forward, two steps back.
That would be my gait. Maybe worse on some days and better on others, but pretty darn close.
This week it's been one step forward, two steps back.
Yeah.
Usually it's two steps forward, one step back.
It is, man, you have to have tenacity to stick with this, I gotta tell you. Like, come on, ROSSerial, why aren't you working? It's like something simple that's supposed to work. Anyway. And Cat can make, I hate, because I don't understand it. I don't understand all the library settings and compiler settings, and yeah, that's just like walking through mud for me. That's why I started this in Python. I'm like, I'm not going to go through all that Catkin stuff. We'll see. Anyway, enough babbling on my part.
Yeah, speaking of ROSSerial, that's one of the next things I want to do is look at that and decide, do I want to go with that and try to use that, or do I just want to continue on and saying, print out this statement that's a message and then there's and decode that when I get it. So, before too long, I'm gonna have to look into that, try to figure that out. And I assume you can tell it, either go out the USB or go out another UART. I think when you configure it, you just tell it what you want to, what you want to talk to. So we'll see how that works out.
I have some notes on sort of starting from scratch on ROSSerial. They're not very clean. But if you get to that point, and one of them, I'm just paging through them as we sit here, is it was finding the right, there's for me, because again, I'm trying to use VS Code and Platform IO to upload code, and you've got to have the library that you use to do that needs to be in sync with the library that's on the, certainly in my case, the laptop that it's going to talk to. And yeah, you have some options. So yeah, I'm happy to tell you more when you get to that point.
And I just went into the examples. I loaded the some kind of ROS package. It might have been the ROSSerial package onto my Arduino, and under examples it says, here's an example that will send out odometry, or an example that blinks the light or whatever, and those load up and run. So it's not. It seems like it won't be that hard. Just to get the examples to run is quite easy, but then trying to merge everything together might get more complicated as they go. So. But anyway, that does seem to be working. But that's just another thing. I just need to sit down and try it here one of these days to see what's going to take to make this stuff work.
And there's a C version and a Python version on ROSSerial too when you start it in your launch file. So that is that's a nuance that you have to decide which of those platforms you want to use.
And that's there's a node that runs under ROS, and you're saying that comes in either Python or C++.
Mm-hmm.
Do you actually modify those? Because it looked to me like I didn't realize how this stuff worked. I started digging into it, and I realized that they've got like 1,000 different message types that you can send back and forth, or maybe it's hundreds of message types, and it looks like basically if you can wedge in what you got there, you don't have to make any modifications, at least on the ROS end. You just start up that node, and all that stuff should work. So that was kind of my impression, but I haven't actually tried that yet.
Yeah, mine, my issues were linked, I think, more to Platform IO and trying to use VS Code and trying to get the library in sync at that level, that not using the Arduino IDE. I think that was part of the root of my issue. But I think I've got it working now and can replicate it when my laptop dies and I have to go back to scratch.
Oh, another comment I was going to make when I was configuring my little Blackpill board and trying to get all my timers set up, and then try to get all my UARTs. Okay, now I need some analog stuff. By the time I was done, I went and pulled up the list, and there's only 4 pins that I can do analog on because everything else has been used up by something else. But I was able to just select 2 pins and say make those analog, and then I had to get somebody's code because being big modern processors, they want you to use DMA on your analog stuff. So they got some really cute stuff if you need it and you're willing to figure it out. Because on my SAMI 2, I didn't think I could just go out and say, like on Arduino, you just say configure the pin and then say analog read on this pin, and it works. I wanted to be able to do that, but when I was looking at it the first time, I couldn't figure out any way to do that. So you either have DMA or something else that was some modern thing. And I actually made that work on SAMI 2. So basically you set it up and say, I want to take analog pins 1, 3, 6, 7, 8, and you put those in a list, and then you start the thing up and it just automatically is reading those for you. So then you can just go out and read, say, array entry 1, which is going to be the first one, array entry 2 will be the second one. And that all worked, but it seemed like way more complicated than I wanted to figure out. So I found some other guys saying, oh, here's how you read a single pin. And he said it's not directly supported. He said it's not supported anymore when you build the code. So I just took his code and copied it in there, and it does indeed work. So I can just go out and say read this pin, and it gives me a value back. And so I got around that. But the thing was, as I say, you've only got so many IO pins to start with, and every time you assign a peripheral, it chews up some of those pins. So when it was all said and done, I got 4 pins that I could use for analog, and I've used 2 of those, and that I still need to have. I need to have like the direction bit for the motor driver, and then there was another one that I thought I needed for either input or output. So, but I think I've got it all to the point where it'll all fit now. I just need to. I just fire it up and then test all the stuff, see what it's doing.
Sounds like a plan.
That's all I got. Oh, what's this? It's colorful.
There's my mute button. I was trying to find the mute button. This is not perfect, but this was my attempt at using it. I mean, it's LibreOffice Calc, but trying to keep track of the pins, their number, and the commands that each of them would take. And I mean, I'm sure you have your own way of doing that, but this just worked partially worked for me, because then on mine, I have the pins on the radio control and then the pins on the tractor, which are, it's the same board, but using different pins, but some are blocked out, like for the LORA, as you were saying, some are standard. I was focused on SDA or I2 squared, I2C stuff. But anyway, having a little layout showing all of your pins and which you do have access, which you don't have access. I also had the complexity of, I created that, I don't know what you call it, daughter board or something, where I was plugging my board into and pulling the pins out. So it all got confusing for me. But it was one way to get it organized. I can't imagine having 100 pins. Although that feels like luxury, it also feels like, oh my gosh, how am I going to keep track of all that?
And then you've also got the concept on these processors. You could remap the pins. So say I assign UART1. Well, if that's going to conflict with something, I can click on something or execute a command. I can move those 2 pins somewhere else on the board. So that frees up those pins for whatever the other peripheral was. And I haven't done any stuff on this one. I haven't done that. Back on SAMI 2, I was moving stuff around to keep it happy. And that's just one more headache to try to figure that stuff out.
Sounds like an FP. What are those boards called? FPGA, field programmable gate arrays, or you can.
It's not quite that elaborate, but yeah, some of the pins you can move and some of them you can't. And the other problem is if you're using their setup tool, you say, okay, give me this UART. It says, okay, I'm going to give you these 2 pins, they're default, and you assign, say, a CAN bus, and it says, well, here, let me move that UART for you. So you have to be careful so it's not moving stuff you don't want it to. But you can, in the setup tool, you can go and you can click on a pin and say lock that down. You can pin it so it doesn't change. So if I want my UART on those pins, maybe the board's already wired that way. So you say assign the UART and then pin those so they can't be moved. So that if I assign something like, say, a CAN bus, it wants to use those pins, but it can't. So it'll grab its alternate pins, or just simply tell you that it won't work, and then it's up to you to figure out after that. So just more stuff you have to learn and play with and fight with to get all that stuff to work.
And then I noticed my ESP32 board that I'm using from this outfit called TTGO. I have version 1 of that, and they're up to like the 6th version, so I can't, you know, it won't be long before people are saying, hey, you need to upgrade to the latest version.
Yep.
Yeah. That's all I got.
Anything from you, Terry?
Just gonna try and get my first goal is to get the Ubuntu 20.04 onto this Acer laptop.
Okay.